This video is on growth hormone secretion and actions. Let's take a look at the growth hormone pathway. We can see the hypothalamus here and the pituitary gland. In this case, we're going to focus on the anterior pituitary. So neurons within the hypothalamus secrete growth hormone releasing hormone, shown here. Growth hormone releasing hormone is secreted into the circulation and travels a short distance down to the anterior pituitary gland, where it then causes specialised cells in the anterior pituitary to secrete growth hormone, which then enters the circulation and travels to its target tissues. Growth hormone targets the liver to then in turn secrete insulin-like growth factors, shown here with the triangles. They then target bone and soft tissue. As well, growth hormone itself targets bone and soft tissue. Together, growth hormone and IGFs promote growth. Now we'll look at this pathway in a little more detail. We'll look at the stimuli for secretion of growth hormone and also the negative feedback loops. The control of growth hormone release is actually quite complex and we still don't understand it entirely, but we do know that circadian rhythms are important for stimulating growth hormone release, and in adults the largest pulse of growth hormone release occurs in the first 2 hours of sleep. Stress can trigger growth hormone release. Also fasting. Given that cortisol is a stress hormone, it's not surprising that this is also linked to release of growth hormone. And growth hormone, as the name suggests, affects growth, but it also has numerous effects on metabolism, which we'll cover soon. So stimuli, such as the ones just described to the hypothalamus, promote the secretion of growth hormone releasing hormone, shown by this positive sign, and inhibit the secretion of somatostatin, shown by this negative sign. Remember that growth hormone releasing hormone stimulates growth hormone release and somatostatin inhibits growth hormone release. So with reduced somatostatin entering the circulation and increased growth hormone releasing hormone entering the circulation, we have a stimulus for the release of growth hormone. Growth hormone then targets the liver and other tissues to secrete insulin-like growth factors. Growth hormone itself also stimulates an increase in blood glucose and bone and tissue growth. Insulin-like growth factors are important for promoting growth in cartilage. Together, growth hormone and insulin-like growth factors promote tissue growth. Let's take a look at how insulin-like growth factor exerts negative feedback. What's shown here is a long loop feedback where insulin-like growth factor inhibits secretion of growth hormone from the anterior pituitary and also inhibits release of growth hormone releasing hormone from the hypothalamus. We also have a short loop feedback where growth hormone inhibits release of growth hormone releasing hormone. Now on to the metabolic effects of growth hormone and IGFs. Growth hormone and IGFs promote protein synthesis, which is an essential part of tissue growth. Growth hormone also promotes fat breakdown. In addition, growth hormone promotes hepatic glucose output. So in this regard, it will increase blood glucose. It'll also increase the levels of circulating fatty acids. This table shows some characteristics of growth hormone, some of which we've already covered, but some of these are new and you'll be hearing for the first time. We know that the origin of growth hormone is the anterior pituitary. Regarding the chemical nature, we know that it's a peptide and it's made up of 191 amino acids. An interesting point with growth hormone regarding its transport in the circulation is that about half is dissolved in the plasma, as we would expect for a peptide hormone, but half is bound to a binding protein whose structure is identical to that of the growth hormone receptor. And in this regard, the binding of growth hormone to this binding protein in the circulation extends the half-life of growth hormone, which is shown here at 18 minutes. So this half-life of growth hormone would be significantly reduced if the binding protein for growth hormone was not present in the circulation. And we've mentioned the factors affecting release. The circadian rhythms are important for stimulating release of growth hormone, particularly during sleep. Circulating nutrients such as glucose can affect growth hormone release, for example, if glucose levels are low. Stress can stimulate growth hormone release, as well as other hormones in a complex fashion,